Hello, pre-calculus students. This is Miss Orloff, and I am going to discuss hyperbolas, the last conic of the section. There are so many real-world uses for them. Satellites, lenses. One of the more, I guess, popular, I guess you would say, is the Loran. It's a radio. It's a navigation radio. And if I have time at the end of this video, I'll show you a clip of how that worked. In the meantime, I know that you guys can read, so I'm not going to read all of this to you. You know, hyperbola is the set of all points in the plane whose distance from two fixed points in the plane have a constant difference. Okay, and so we are learning about these points and all these hyperbolas and the relationship in the parabola, the focal point, and the directrix, which was a line. We talked about that. In the ellipse, we had two focal points, the foci, right? And so in the hyperbola, we also have two focal points, all right? And you can go ahead and read through that. And we're going to have vertices. We're going to have some asymptotes. We're going to have some all kinds of cool things going on. So hyperbolas have, we have two versions. We call a horizontal focal axis, and we have a vertical focal axis. And what determines that? Well, I'm going to look at the two standard forms of the equations right here. And unlike the ellipse, where we had a sum going on in the equation, and a sum, we have commutative property, right? So it didn't matter who came first. We have a difference here. And also, unlike the ellipse, where our A in an ellipse was a bigger number than our B, that is not true for a hyperbola if you're thinking about it in an absolute value form. So what makes that decision? My positive term is the winner. If x is in the positive term, then the hyperbola opens up horizontally, left and right. If y is the positive term, then the hyperbola opens up and down. You can see I have the subtraction, but I can also write that as an addition plus a negative, and that is why I call this term my negative term. I really like to avoid saying the first term. I can write that differently, where my first term doesn't have to be positive. So I'm looking for that positive term. We have all of these other things you can memorize. I really don't. And I am a visual person, and I'll approach drawing hyperbolas as thinking about the visual and coming up with labeling all these things after I kind of get a rough sketch. But you can see the focal axes. If it's horizontal, it's horizontal. Y equals some constant. If it's a vertical hyperbola, we have a vertical focal axis, x equals h. The focal points and the vertices, if you would like to memorize these relationships, fine. Again, I don't. It is important that I think about the semi-transverse axes is A, and the semi-conjugate axes is B. Semi, half of it. So the length of the transverse axes would be 2A, and the length of the conjugate axis would be 2B. So I have this diagram drawn here. And you're going to see these dotted lines, asymptotes, right? So if we look at that, we also have a relationship. The neat thing is you're going to see the center within the equation of the asymptotes. And I have a slope. Students like to memorize it. Fine again. I don't. Again, I do this visual. So, vertices. I'm going to plot these and emphasize these in red. Okay. Notice the difference. A hyperbola has the focal points further out than the vertices, unlike the ellipse. And the hyperbola, like the parabola, likes to hug those focal points. So notice that I'm talking about this. This is my semi-transverse axis, half of it. That's the entire one is the entire transverse axis, correct? And it connects the vertices. Notice how I had drawn that again up here and here. And then you're going to see that I have this conjugate axis actually comes in here, but I did this here and here because I made these rectangles. Those rectangles help me draw the hyperbola. Here's a fun fact, and I wish I had more time to get into this with you. I do not have time to get into it with you. There is an ellipse that corresponds to the hyperbola that fits in here. That looks more like a circle, I get that. But I want you to notice that we do not see the focal points of the ellipse. They would be different than the focal points of the hyperbola. There's a lot of things that you would have to think about, but I just wanted you to see that. Okay. This is a relationship that you will have to know. You will have to know this for any assessment. You'll have to have memorized. Is the Pythagorean relationship of c squared equals a squared plus b squared. That's one you're probably a little bit more comfortable with compared to the other Pythagorean relationships. So, I believe I've got this great summary from my colleague, Mr. Wilson. But I would love for you to pause the video and read the summary. Okay, hopefully you read through that summary. It's a really good, just something to go back and reflect on, as well as these steps of how to sketch a graph. These are steps that I follow. I want to also suggest again that you pause the video, take a look at those steps, but I will be going through them quickly with you as we draw our very first hyperbola. So when I say determine the transverse and conjugate axes, what I'm really thinking about is what direction does this open? Is the x with the positive term or is the y? And in A, it is the x. So I do have a horizontal hyperbola. I know that a squared is 9 and b squared is 4. So the directions of my axes. So if I think about my transverse axes, right, that the semi-transverse axes, A equals 3, B equals 2, right? We're going to use that to find my transverse axes. But first I think I want to plot my center. So let's go ahead and do that. My center will be at 2, -1. And now I'm really comfortable getting into deciding those axes and taking that time to draw that rectangle. So I'm going to go ahead and go 3 points, 3 units out from the center in the horizontal direction, in each direction, the positive and the negative. Those are my vertices of the hyperbola. They're also the endpoints of the transverse axes. I should expect the transverse axes to be a length of 6. Okay? And then my conjugate axes, I'm going to go vertically up 2 because B is a length of 2, and then down 2. And then I'm going to put in this imaginary rectangle. By the way, you are hearing potentially my dog Izzy snoring in the background. She just loves being at my side. I apologize. So I did that box in gray, so it's kind of faint. Okay? And so I have my vertices, I have the points there, I plotted them, you guys can tell the points, but what I don't have are the focal points. So I need to think about that Pythagorean relationship. So the Pythagorean relationship, c squared equals a squared plus b squared, right? So c squared equals 9 plus 4. So c is approximately the square root of 13. I did not do plus or minus, right? Because I'm thinking about a length right now, but I do know I need to move so many units in a positive direction, so many in the negative. Square root of 13. The square root of 13 is somewhere between 3 and 4. I also know that my hyperbola needs to hug that. So those points need to go in the horizontal direction. So I'm going to go a little bit past 3, somewhere between 3 and 4. I am estimating that distance, and those bright green points are my focal points. I'm almost ready to draw my asymptotes, or my hyperbolas. I have to draw the asymptotes first. They go through the corners of the rectangle. They also hit the center. So they hit a corner, center, corner. And this is why I do not need to memorize the equation of the asymptotes. I can now figure out my slope is up 2 over 3, and it goes through the center. So if I had to write the equation of that, I would think of point slope form, y minus y sub 1. So in this case, y minus -1, so y plus 1 equals, I have plus or minus the slope of 2/3 times x minus 2. Now, I chose point slope form because it's the easiest form to write it in, and I need to be careful if I have to simplify it. Those two lines have different y-intercepts. Now I'm going to just rough sketch in that hyperbola. I'm going to go for my vertice, and I'm going to follow along the asymptote. That gives me my end behavior. What the graph will look like is x goes off to infinity, just kind of follows along those lines. Okay, pause the video and do B. Okay, here's my work. Take a moment, pause the video, and check it out. Okay, we're going to move on to problem number 1. Find the vertices and foci of the hyperbola given this equation. So this is different than what we did before. Look at that. Y is positive. This is a vertical hyperbola. I know my center is at 0, 0, so I'm going to just start like a rough sketch over here. This is for me, my use. Like I'm just doing this to help myself. I know a squared equals 25, therefore a equals 5. So I'm up 5 units, and I'm at the ordered pair 0, 5. I'm also down 5 units at the ordered pair 0, -5. I wasn't required to do a graph, okay? I want to be clear about that. I am just asked to find the vertices and the 2 focal points. So I found my vertices. Okay. My focal points. Well, I just need that relationship of c squared, c squared equals a squared plus b squared. So c squared equals 25 plus 21. So c is going to equal the square root of 46. I can't think about that as a plus or minus. I'm going to add it or subtract it. It goes in the same direction as the vertices. So 0 plus or minus the square root of 46. We got lucky there because our center was at 0, 0. The equation, number 2, we're going to find the equation of the asymptotes. This is really where I need that visual piece. First thing, I need to know the direction in which it opens. X is that positive term. y has this attached to it. It opens horizontally. So again, I'm doing that rough sketch with the center at 0, 0. A equals 3. So I go out 3 units this direction and 3 units this direction. B is 4. 4 units up, 4 units down. I have my slope. Up 4 over 3. I also know that the asymptotes would come through that center. So y minus 0 equals plus or minus 4 over 3 times the quantity x minus 0. Again, using that point slope equation. It's the easiest one to use. Find the endpoints of the transverse axes and the conjugate axes. I'd like you to pause the video now, find the center, find A, and find B. Okay, you can see I found the information I asked you to find. I can tell that my x-coordinate, or my term with x in it is positive. I'm moving horizontally. So the endpoints of my transverse axes, I need to move 12 units this way and 12 units that way. So I've got to think about that. In the ordered pair 1, negative 3, the y doesn't change. Y stays negative 3. But I'm going to add 12 to 1 and get 13. And I'm going to subtract 12 to 1 and I'm going to get negative 11. And there's the ordered pair of my transverse axes. To save time, I'm just going to put t's by them for the endpoints of the transverse axes. The conjugate axes, I'm going to go from the center 5 units up this way and 5 units down this way. Now my x changes, but my y does not. So I add, my y changes, my x does not. I'm not sure if I said that properly the first time. So x stays 1, and I have 5 plus negative 3, and I get 2. And then negative 3 minus 5, and I get negative 8. That's a 1 comma negative 8. So these are the endpoints of my conjugate axes. So now is the time where I really think you need to practice. And so you should really go through number 4 and number 5, pause the video, work through this, and really do an honest effort on this. And then come back, check your work against mine. Pause the video now. Okay, take a moment and look at my work on number 4. If you're struggling with this is something you want to contact your teacher and have a conversation and work through some of these problems. On number 5, I think we're going to do it in parts. I'm going to give you hints just in case you got stuck. So I plotted my points for the transverse axes. Since that's a vertical transverse axis, this hyperbola opens vertically, up and down. Okay. My next goal would be to find the midpoint of that line. Pause the video, do that if you haven't already. You should have found the center to be negative 2, negative 1. Therefore, A is 8. So if A is 8 and the asymptote slope is 4/3, and I know my slope is going to go up so many and over so many, I have to do a proportion. 8, which represents A, so this is A, over B in this scenario, over B. And I need to solve that proportion. Pause the video and go. So that was the challenging part, getting that proportion. Now we're good to go. Write your equation. Woo, feeling good. We're going to skip 6 because this video is already getting lengthy. So I don't want to keep things going because we really need to do something like this. Algebra. Take a deep breath. Let's work through it together. Not a big deal. We're going to work through it together. No stress. But I need to just do a lot of completing the square. So here's what I'm going to do. I'm going to say, well, the x's like to be together, and the y's, they're good friends. So we're just going to gather them. So I have 9x squared. I like to write things like this, plus negative 36x, just who I am. And then plus negative 4y squared plus 8y. And I'm going to get this constant just out of my way. So I'm going to treat this as two different groups. I'm going to complete the square on the yellow group and complete the square on the blue group. Everybody has a different method for completing the square. I'm just going to go through what my instinct is. And first thing I need to do is factor out 9. And then in the blue grouping, I am going to factor out negative 4. Because to complete the square, I need a leading coefficient. So after I complete the square, I create these perfect squared trinomials. But I have to balance the equation. Take a deep breath here. Don't rush. I did not add 4. I added 9 times 4. I did not add 1. I added negative 4 times 1. So I'm going to clean this up. But that should be an equal sign. It's not a mistake if I catch it. I need it equal to 1. So no matter what, even if this doesn't divide pretty into these things, I got to divide by 36. I was nice, made it pretty. So my hyperbola. Man, you guys were great. This was a longer video. I appreciate your focus. We are done with conics other than practicing and mastering it. I promised you a video about the Loran, but I'm thinking I'll just add that in somewhere else. Again, it is the Loran radar system. It was used in wars. It's something you might want to look up, and it's really cool with the hyperbola. You guys are all rock stars. Have a good one.